Today we're going to be talking about the equation of a circle, as in how do we use x's and y's to describe a circle on a grid. Previous years, you know a few things about circles. You know the area of a circle formula, pi r squared, and the circumference of a circle, 2 pi r, or that's the same thing as pi d, pi times the diameter. But today we're going to be looking at them on a grid. In some of the applications, you will need those formulas. Okay, so by the end of class today, you should be able to state the equation of a circle if you know the center and its radius, state the radius of a circle if you know its equation, and determine algebraically if a point lies inside or outside or on the circumference of a circle. And there will also be some application questions. So I've opened up a GeoGebra file, and I'm just showing you here a circle that has a center of 0, 0 and a radius of 1. And if I take my radius slider and I move it to the right, I can get a radius of 2 and 3 and so on. And you can see the center of the circle is always at 0, 0. And if we're looking at the x and y intercepts of this circle, it's interesting that they are always at the same number that's at the radius. And of course that makes sense. So here we go, as we change the radius, the x and y intercepts all change accordingly. Of course, when you go up, it's a positive, and to the right it's positive, and down and left have the negative values. So I've got a circle with a radius of 5 now. As we can see, it points to 0, 5, and so on around the axes. If I put a point on the circle, and I move that point around, it doesn't surprise that the coordinates of that point keep changing, but the radius, or the length of this line segment here, stays constant at 5. So my question is, can we relate the radius to anything algebraically? So there is an exact point that lies on that curve, 3, 4. And I'm wondering if we took this x-coordinate of 3, realized it was the length across the x-axis, and the y-coordinate of 4, which is the distance up, that we would get a right-angle triangle, and a 3, 4, 5 is a Pythagorean triple. So that's going to help us develop a formula for the algebraic equation of a circle. Okay, so for the formula of an area of a circle, it looks a lot like the Pythagorean theorem, where the radius squared will be like your c squared, and that will be on the right-hand side of your equation. So x squared plus y squared equals r squared is the general equation of a circle. You need to memorize this. So what is the radius of this circle here that's given? X squared plus y squared equals 81. Well, r squared is 81. To get r, we need to take the square root of both sides. So r would be positive or negative 9. But of course the negative doesn't make sense because the radius is a length. So the radius would be 9. Okay, we could use the formula in a different way. Say, give the equation of a circle with center 0, 0 and a radius of 4. Well, we want to put in a value for r squared, and we know r is 4, so we have to square it. And of course, we would get the answer 16. So x squared plus y squared equals 16 would be the equation of a circle, center 0, 0, and a radius of 4. Okay, question 3. What is the relationship between the point 4, 6 and the circle x squared plus y squared equals 49? So what we need to ask ourselves, is this point inside the circle, on the circle, or outside the circle? So we could take a picture of this and imagine we've got our circle, x and y axes, and my radius of this circle would be 7. So that would be the point at 7, or 7, 0, and this would be at 0, 7. And the point 4, 6 is somewhere around here, but I'm not exactly sure where. Not sure if it's inside, on, or outside the circle. So let's take a look at some algebra. The 4 is the x, and the 6 is the y, so let's put them into the equation and see what happens. So we have 4 squared plus 6 squared on the left-hand side. So that would be 16 plus 36, and that would give us 52. And now we need to compare 52 and 49. So if I had the circle with the equation x squared plus y squared equals 52, it would pass through the point 4, 6, because 4, 6 would work in that equation. But that is, radius squared is bigger than this radius squared. So this point must therefore be outside the circle. Okay, so now you need to ask yourself the question, can you state the equation of a circle if you know the center is 0, 0 and its radius? Can you state the radius of the circle if you're given its equation? Can you determine algebraically if a point is inside, on, or outside the circumference of a circle? Then you're going to complete this homework up to number 19. You can choose 18 or 19, and if you'd like a challenge, you can keep going, and if you find some of the easy ones too easy, trade them for a harder one at the end.